division. And Mohammed, I'll answer that question after class. I'll write down these solutions and then I'll send it back to you through your email. So when we talk about quotient rule, when it talks about differentiation and finding the derivative, it has to do with a function p of x over a function f of x over the function g of x. So example one, we want to show that if h of x is equal to f of x over g of x, where f of x is 6x cubed minus 1 and g of x is 2x, then we need to show that the derivative of h of x is not equal to the derivative of taking both f of x over g of x separately. So we have h of x. So h of x is equal to f of x over g of x. So you have 6x cubed minus 1 all over 2x. So now I can simplify this even more. So I can use my 2x as my common denominator for both. So I get 2x cubed divided by 2x minus 1 over 2x. And then I can start simplifying. So 3x cubed over 2x, what would that simplify into? (3x squared) minus 1 over 2x. Okay? Or we can also write it as 3x squared minus 2x to the power of negative 1. So now I can take my derivative. So I get h prime of x is equal to, so we're going to be using the product law, which means that I can take the derivative of the first one and add it to the derivative of the second one. Okay? Sorry, this should be 1 over 2x to the negative 1. I forgot to keep the fraction. All right. So remember, h prime of x, if I have p of x and g of x, is just the derivative of p of x plus the derivative of f of x, or g of x, sorry. So what would the derivative of 3x squared be? So what would be the derivative of 3x squared? It would be 6x. Okay? And now I can take the derivative of negative 1 half x to the negative 1. And what does that give us? Anyone want to give me the derivative of negative 1 half x to the negative 1? Yeah, I got positive 1 half x to the negative 2. Or if we simplify it, we get 6x plus 1 over 2x squared. Okay, so this would be the derivative of h prime of x. Now, we're going to do it the other way, where we do each of them separately and combine them as a fraction. So we're going to take f prime of x over g prime of x. So if we look at 6x cubed minus 1, what would the derivative of 6x cubed minus 1 equal to? (18x squared), perfect. And what is the derivative of 2x? 2. So now we can simplify. This becomes a 9. So f prime of x over g prime of x is equal to 9x squared, which means that the derivative of h of x does not equal f prime of x over g prime of x. And this is where we get started on talking about the quotient rule and how we can actually, use a specific rule to help find us the derivative of the quotient, which is where two functions are on top of each other as a fraction. So here we have the quotient rule. So if the function f of x and the function g of x are both differentiable, and h of x is equal to f of x over g of x, then the derivative of h of x is equal to the derivative of the top function, so f prime of x, multiplied by the function at the bottom, g of x, subtract f of x times the derivative of the denominator, all over the denominator squared. So if you were to say it in words, it would be the derivative of the top times the bottom, minus the top times the derivative of the bottom over the bottom squared. So now we want to use the same example above. So we have f of x is 6x cubed minus 1, and we have g of x is equal to 2x. So once we combine them, we get h of x is equal to x cubed minus 1 over 2x. So now given our rule, so this would be considered f of x, and this would be considered g of x. So following the rules from the top, can someone give me the numerator? Remember, we're taking the derivative of the top times the bottom minus the top times the derivative of the bottom. So what's the derivative of 6x cubed minus 1? What would that be? (18x squared). So we get 18x squared times the bottom, which is 2x, minus the top, which is 6x cubed minus 1. And what would the derivative of my denominator be? Derivative of 2x, what is it? 2. And then all over 2x squared. All right. So now we can expand and simplify. So if I expand my numerator, what does it turn into? So I have 18x squared times 2x minus 6x cubed minus 1 times 2 all over 2x all squared. So what would my numerator and denominator simplify to if I were to expand them all out? Yep, so if we expand and simplify, I'm just going to expand first and then simplify after. So I got 36x cubed minus 12x cubed plus 2 and basic grade 9 exponent laws for x squared. So I got 36x cubed minus 12x cubed, which is 24x cubed, plus 2 all over 4x squared. So now what I can do to factor out from the top and the bottom is I can factor out a 2, or what you can do is also make 4x squared the denominator for both 24x cubed and 2. So what I mean by that is you can write this as 24x cubed over 4x squared plus 2 over 4x squared. Now, if I were to simplify that, what would my final derivative be? So you get 6x plus 1 over 2x squared. So this is what your derivative of h pound of x would be. I don't know why this screen is uncalibrated today, so I'm going to probably fix that during our break. As you can see, doing the quotient rule involves just following this set of steps, and you'll be able to find your derivative of h of x if it's two functions over each other as fractions, but both functions have to be differentiable. I'm going to give you guys time to copy this down, and then I'll move on to the next thing. And Mohammed, just remind me before break, or towards the end of class, what the question was you wanted me to take up. All right. So now let's move on to our next example. So we are over here. All right. So we have f of x is equal to x squared plus 2x minus 3 over x cubed plus 1. So our numerator can be considered p of x, and this can be q of x. So now we need to determine the derivative of this function using our quotient rule. So remember, it's the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Okay. So what would the derivative of my top function be? X squared plus 2x minus 3. Right, we get 2x minus plus 2 times my bottom, which is x cubed plus 1, minus, what would the derivative of the bottom be? What's the derivative of x cubed plus 1? 3x squared times x squared plus 2x minus 3 all over x cubed plus 1 to the power of 3. You can write it like that, all squared. Now, as you can see, we have a sum of cubes on the inside. So if you don't remember how to expand a sum of cubes, I'm just going to write it down over here. So beside, if we have something that is a cubed plus b cubed, you can break it down to be a plus b times a squared minus ab plus b squared, okay? Or in turn, if you have a sum of cubes at the bottom as well, you get a cubed minus b cubed, which is a minus b, times a squared plus ab plus b squared. So we're not going to expand the denominator just yet, but we can expand it in terms of a sum of cubes. So I'm going to basically simplify my numerator, which gives me 2x4 plus 2x cubed plus 2x plus 2 minus 3x4 minus 6x cubed plus 9x squared. All you're doing here, guys, is just foiling the two brackets in the numerator, and you are leaving the denominator alone for now, which gives us x cubed plus 1 cubed over to the power of 2. And now I can simplify my numerator and also simplify my denominator. So if you guys were to collect like terms in the numerator, what would my numerator simplify into?
Ruby's backing out after his whack out.
Nanup, I think your mic is on. Okay, so what would my numerator simplify into? Yep, thank you, Mohammed. So I get negative x4 minus 4x cubed plus 9x squared plus 2x plus 2 all over. Now I can expand my denominator in terms of a sum of cubes, which means I will get x plus 1 squared, because we have to keep the squared, times x squared minus x plus 1 all squared. So this would be the derivative of f of x in the most simplest form. Okay. We're going to do B next, and then for example C, you guys are going to do it on your own. All right, so this is the simplest as it gets, as we cannot factor any further, or we cannot cancel out any like factors from this function, or from the derivative of the function. And if some of you are wondering the reason why both brackets in the denominator are squared, is because technically I can rewrite this as a, like I said, a sum of cubes as a square bracket. And then I can have my x cubed plus 1 cubed on the inside with my power of 2 on the outside, which just becomes, again, x plus 1 times x squared minus x plus 1, all squared. And because of exponent laws, where does my power of 2 get distributed into the bracket? Does it get distributed to both brackets or just one bracket when I expand it into sum of cubes? It goes both, okay, because each one has a factor, an exponent of 1. So this 2 goes to that exponent or that factor, and this 2 goes to that factor, which means I get x plus 1 squared times x squared minus x plus 1, also squared. Did anyone have that question, or did you guys already assume that's what was happening? If you did have that question, now it's answered. If you knew, then that was just a refresher for you guys to do it. I'm going to give you guys a minute to copy this down before we move on to our next example. All right, so move down to the next one. So the next one we have y is equal to root of x over x squared minus 1. All right. So we can also write this as x to the 1/2 over x squared plus 1. So if we want to find the derivative of y, what would my first line end up looking like? Oh, that's fine, Sebastian. So again, what would be the derivative of x to the 1/2? What is that going to look like? One over 2, x to the what? Remember, we have to decrease the exponent by 1. So it would be 1 over 2x to the negative 1/2, because 1 over 2 minus 1 gives me negative 1/2. Okay, and the bottom stays the same, so we get x squared plus 1, and we get minus, what is the derivative of the bottom? Two x, thank you, Priyanshu. We get 2x times x to the power of 1 over 2, all over x squared plus 1 squared. So again, we don't really need to expand our denominator, so we'll leave it as is, but we need to FOIL our numerator and simplify. So I have to multiply 1 over 2 x to the negative 1/2 times x to the power of 2 plus 1. So we get 1/2 times 1, which is 1/2. And when we do x to the negative 1/2 times x to the 2, what does our new exponent become? So remember, exponents with the same base, you add the exponents, so we need to add negative 1/2 and 2. what would that give us for our new exponent when we simplify? Three over two. So it'd be 1/2 x to the power of 3 over 2 plus 1/2 x to the negative 1/2 minus, so again, exponent laws, 2x, and then we have 1 plus 1/2, which gives us 3 over 2. All over x squared plus 1 to the power of 2. So now we collect the like terms, so we can simplify this even more. So my only like term here is going to be 1/2 x to the power of 3 over 2 and negative 2x to the power of 3 over 2. So if I were to simplify that, what is 1/2 minus 2? What does that give us? Thank you, Anna. Negative 3 over 2. So I'm left with negative 3 over 2, x to the power of 3 over 2, plus 1/2 x to the negative 1 over 2, all over x squared plus 1 to the power of 2. So now if I want to get rid of the fractions on the numerator, what can I multiply my numerator and denominator by to get rid of that fraction at the top, to get rid of the fractions at the top? What can I do to get rid of my fractions? We're going to multiply both the top and the bottom by 2. So I do times 2 here, times 2 over here, which gives me negative 3x to the power of 3 over 2 plus x to the power of negative 1/2 all over 2 times x squared plus 1 to the power of 2. All right, so let's see if we can do anything else. Is there any factor in the numerator that I can take out? Okay, we can take out a negative x to the negative 1/2. So let's factor out negative x to the negative 1/2. Once I factor that out, I'm left with 3x squared minus 1 all over 2 times x squared plus 1 all squared. Because we don't want a negative exponent in the numerator, all we're going to do is take x to the negative 1/2 and bring it to the bottom, which gives us negative 3x squared minus 1 over 2 times the root of x multiplied by x squared plus 1 all squared. You don't have to bring the negative back in. You don't have to do that. You can leave it as this. So that means the derivative of root of x over x squared plus 1 is negative 3x squared minus 1 over 2 times the root of x times x squared plus 1 all squared. So again, it's just step by steps. It just takes a bit of practice, and you'll get very, very much used to it. Yes, Anna.
Would we be able to would you want us to simplify, because you know how it's like negative and then it's like bracket 3x squared? Would you want us to put the negative inside to make it?
You can choose to. I'll accept both answers. You can put negative on the outside if you want to expand it in. I'll also accept that answer as well. So I'll take both. If you choose not to expand it or bring the negative in, I'll take this answer. But if you want to bring it in, and have your numerator be negative 3x squared plus 1, that's also fine with me. Okay. Give you guys a minute to do this. And then for the next example, example C, I want you guys to work on that on your own. And I'll let you know when to do that as soon as you guys get a minute to copy this down.